Hello everyone. In this session, we are going to discuss about concept of measurements in engineering metrology and measurements. Before that, I heartily welcome you all. Metrology. What is metrology? Metrology word is derived from Greek words such as metro means measurement and logy means science. So metrology is a science of precision measurement. The engineer can say it's a science of measurements of length and angle and related quantities like width, depth, diameter and straightness with a high accuracy. Metrology is concerns with the establishment, reproductions and conservations and transfer of units of measurements and their standards. Next, measurement. So what is a measurement? Measurement is defined as the process of numerical evaluations of dimensions or otherwise the process of comparisons with standard measuring instruments. The basic aim of the measurement in industries to check whether a component has been manufactured to the requirement of the specifications or not. The elements of measuring systems include the instrumentations, calibration standards, environmental influence, human operator limitations and features of the workplace. Next, we are going to see about types of metrology. So basically, it's three categories. First one, industrial metrology, and second one, scientific metrology, and third one, legal metrology. So what is industrial metrology? Industrial metrology's purpose is to ensure that instruments used in a wide variety of industries are functioning properly. Next, scientific metrology. This form of metrology deals with the organizations and development of measurement standards and with their maintenance. So next category, legal metrology. So legal metrology is the part of metrology which treats unit of measurements, method of measurements and the measuring instruments in relation to the technical and legal requirements. The activities of the service of legal metrologists are control of measuring instruments, testing of prototypes or models of measuring instruments, examinations of measuring instruments to verify its conformity to the saturated requirements, etc. Next, objectives of metrology. Although the basic objective of a measurement is to provide the required accuracy at a minimum cost, metrology has further objectives in modern engineering plan with the different shapes which are complete evaluation of newly developed products, determinations of the process capabilities and ensure that these are better than the relevant component tolerances. So next, determinations of the measuring instrument capabilities and ensure that they are quite sufficient for their respective measurements. So next, minimizing the cost of inspections by effective and efficient use of available facilities. Next point, reducing the cost of rejects and rework through the applications of statistical quality control techniques. So next point, to standardize the measuring methods to maintain the accuracy of measurements, to prepare the designs for all gauges and special inspections fixes. So these are the features we are achieving from the metrologies. So next we are going to see about method of measurements. So these are the methods of comparisons used in measurements process. In precision measurement, various methods of measurements are adopted depending upon the accuracy required and the amount of permissible errors. The method of measurements can be classified as 10 categories. So what all that? direct comparisons, indirect comparison, comparative method, coincident method, fundamental method, contact method, transpositions method, complementary method, deflections method, and final one, contactless method. So the first one, direct method of measurement. So, what is direct method of measurement means? This is a simple method of measurement in which the value of the quantity to be measured is obtained directly without any calculations. For example, measurement by using scale, vernier caliper, micrometer, bevel protractor, etc. This method is most widely used in production domains. This method is not very accurate because it depends on the human insensitivity in making of judgments. So next one, indirect method of measurement. In direct method, the value of quantity to be measured is obtained by measuring other quantities which are functionally related to the required value. For example, angle measurement by the sine bar, measurement of a screw pitch diameter by 3-wire method, etc. So next, comparative method. In this method, the value of the quantity to be measured is compared with the known value of the same quantity or other quantity practically related to it. So in this method, only the deviations from the master gauge are determined. Example, dial indicator usings or other comparator usings. So next one, coincidence method. It's a differential method of measurements in which very small differences between the value of the quantity to be measured and the references, which is determined by the observations of the coincidence of certain lines or signals. For example, measurement by the vernier caliper micrometer. So next one, fundamental method. It's based on the measurement of the base quantities used to define the quantity. So contact method. It's a method of direct comparisons in which the value of quantity to be measured is replaced by a known value of same quantity. So selected that the effects produced is the indicating device by these two values are the same. So next topic, transposition method. It's a method of measurement by direct comparisons in which the value of quantity measured is first balanced by an initial known value A of the same quantity, and then the value of a quantity measured is put in place of this known value and is balanced again by another known value is a B. If the positions of the element indicating the equilibriums is the same in both the cases, the value of the quantity to be measured is A and B. For example, determinations of a mass by means of balance and known weights using the Cox double weighing balance. So next one, complementary method. In this method, the value of quantity to be measured is combined with the known value of same quantity. The combinations is so adjusted that the sum of these two values is equal to predetermined comparisons value. For example, determinations of the volume of a solid by liquid displacement. So next one, deflection method. In this method, the value of a quantity to be measured is directly indicated by a deflections of a pointer on a calibrated scale. Next one, contactless method. It's a method of differential measurement. In this method, the differences between the value of quantity to be measured and the known value of a same quantity with which it is compared is brought to zero. So next we are going to see about generalized measurement systems. A measuring systems exists to provide information about the physical value of some variable being measured. In simple cases, the system can consist of only a single unit that gives an output readings or a signal according to the magnitude of an unknown variable applied to it. However, in more complex measurement situations, a measuring system consists of several separate elements as shown in the figure. A generalized measurement systems consist of the following components: primary sensing element, variable conversions element, variable manipulations element, data processing elements, data transmission systems, and data presentation elements. And today's topic was over. Next we will meet on another topic. And these following books are some references related to our topics. Engineering Metrology and Measurements is a textbook by Raghavendra and Krishnamurthy, and references book Engineering Metrology by Gupta, Instrumentations and Mechanical Measurements by Jayal, and Mechanical Measurements by Bhagwat et al. And further, I'll give some link from the NPTEL portals. So these are references for our guidance. So thanks for watching. Thank you.